Dear students, I welcome you for the today's lecture related to the vessels or types of the vessels, or you can say the pressure vessels, different vessels. Now, what are the different vessels that will be used in our process industries? It is mostly or commonly we talk related to the pressure vessels, in which it can be a reactor, it can be a distillation tower, it can be a heat exchanger, a evaporator, a absorber, a separator, scrubber, or the storage tank, or even the reactors or the vessels in the vacuum or the high pressure vessels. All these are the different types of the vessels. However, the general terminology vessel that is associated with it, whether it's a pressure vessel, whether it's a high pressure vessel, or whether it is the under vacuum, or whether it's a distillation column, everywhere there is a vessel. The internals of that vessel, that can be the different depending on the functioning of that vessel. Because in a reactor, when you talk, the reactor consists of an agitator, then the impeller associated with that agitator, then certain baffles. If you talk about the heat exchanger, the outside of the heat exchanger, it is again a vessel, and inside of that, the tube bundle that is associated. So that outside of the heat exchanger, outer part of the heat exchanger, that is nothing but a pressure vessel. Similarly, in the case of a distillation tower, we can see the different plates or packings that will be available in a distillation column. But this is all assembled inside of one vessel. So outer part that is available, that is nothing but a vessel, which is a closed vessel mostly, as our chemical reactors, chemicals are we are using. So it is mostly a closed vessel. So these are our different types of the vessels, and everywhere the designing procedure for the vessel, whether it's a reactor, whether it's a distillation column, heat exchanger, evaporator, or separator or scrubber, it's mechanical aspects of a designing, that is consideration of a stress, strain, and calculation of a thickness depending on the pressure, depending on the operating pressure and temperature conditions. So these are the main important considerations, that is your temperature, pressure. Based on that, I'm going to consider a material, and that material, it will have a certain stresses, and with the operating conditions of pressure, I am going to calculate a certain thickness. So ultimately, it's a calculation of a thickness, which is very important in the designing of the chemical equipments in the mechanical aspect. Chemical aspects, you have to consider the mass transfer aspects when you design the your mass transfer equipments like your distillation columns, absorbers, humidifiers. All these are your mass transfer operations. If you talk to the heat transfer or heat associated equipments, that is your heat exchangers, evaporators, coolers, condensers, all these are your exchanging equipments. Now, these parts basically talk, it is related to the flanges and supports, then the heating systems. So all these are our different the different parts of a vessel, that is our heads, flanges and gaskets, nozzles, supports, certain heating systems, whether it's a jackets or coils, and when you talk related to the internals of the individual chemical equipment, then it can be the different. In case of reactors, our agitators and baffles will be there. In case of a distillation tower, it's a packing or the different types of the trays, downcomer, gear that will be there. In case of a heat exchanger, your tube bundle that will be associated with that, and the number of tubes will be associated, baffles, all these, the internals that is going to vary. Now, this subject of chemical equipment design, it is generally, or when you talk, it is discussed in terms of a reactor. General consideration first, and then we are discussing in details related to the reactors. And that is also the simple reactor. And we are going to discuss the mechanical aspects related to this subject. So it's a link between a mechanical engineering and a chemical engineering, where you need the necessary associated with the products, the designing that will be there. So the knowledge of this designing, fabrication and operation and its day-to-day maintenance activities, which is very much essential in this subject. The outcome what is expected from this subject is that you should be able to design the different chemical equipments. You should know the different fabrication techniques of the vessel and how the different operation wise or maintenance wise, what are the basic requirements. तो फ्लैंज लीकेजेस है, नोजल्स में कुछ डैमेज है, देन सपोर्ट सिस्टम्स बेटर नहीं है, एंड इन एडिशन टू दैट whatever the design or whatever the fabricated equipment handed over by the mechanical engineer, that is to be properly, whether its performance is proper or not, it has to be evaluated by the chemical technologies. That is the role of this subject in our syllabus. Now, when you talk related to the different applications, so in our household vessels, pressure cooker it is also there. Then your domestic hot and cold water drums, that is your geysers. Then storage cans. Then tiffin boxes, water bottles. All these your household applications of this, or you can say the smaller versions. Then coming to the industrial part, you will having the different chemical equipments. In addition to that, the different utilities that will be also required. That is the industrial compressed air receivers, then domestic hot water storage tanks, diving cylinders, then storage vessels for liquefied gases such as ammonia, chlorine, propane, butane, and or again the regular using of LPG cylinders. That is nothing but a pressure vessel. Its pressure is around 14-15 kgs per centimeter square, and to sustain that pressure, these LPG cylinders are having a sufficient thickness and strength of the material that is already well designed, so that it should not leak, it should not get easily exploded until and unless there is very huge fire that will be there. So all these considerations, these LPG cylinders, they have been designed. The pneumatic and hydraulic reservoirs, then recompression chambers, all these are chemical equipments, and all these are used in our chemical plants. Petroleum refining, petrochemical plants, your paint industries, polymer industries, textile industries, food and oil industries, pulp and paper industries, Not only that, the pharmaceuticals, cosmetics, and to a higher or a well safety considerations, our nuclear industries also. Now, this is the general figure related to our reaction vessel, which incorporate a vessel which is associated with the basic consideration. This is the basic vessel which you can see, and to this vessel the different accessories that is attached. So with a certain purpose, all these accessories are there. This is the basic vessel which I have shown here. Then next is our head. This is the head. This is the upper head or the, and there can be a bottom head also. Top head as well as the bottom head also. The two heads that can be attached to a cylinder. Then there can be the jacket which is associated with this. This is the heating jacket which is provided around this vessel. So I have provided the jacket around this vessel for supplying the heating fluid. This is what the jacket that is to be provided for heating purposes. Or sometimes instead of providing the jackets, I can provide the coils, internal coils inside his vessel. So I can have the inlet and outlet for these coils for supplying the heat or removing the heat. Then there can be a agitator which is provided, the agitator shaft which is provided at the center, and the impellers which is connected to this agitator shaft. And this agitator shaft that is connected to a motor, then a speed reduction box or gear box that will be provided, and then the coupling that will be provided. So when you talk related to the agitator, it's a motor, then the speed reduction chamber, then the coupling that will be there, then there will be the shaft which is provided, and the impeller that will be provided. So when you talk related to the agitator, it's a all assembly of the impeller, shaft, the speed reduction gearbox, and the motor. That assembly is considered to be as the agitator, and this is all attached to the vessel. Then the inlets and outlets that will be provided to this vessel. The inlet will be there, and the certain drain holes or the outlet or the product taking, you have to drain out the product, or sometimes the product, if it is a continuous process, the product will be taken out from the upper part also. So that depends on the operation. Then there are the deep plates they are provided, which is used for the pressure measurement or the liquid height which is available in the vessel. Then the baffles will be provided, which reduces the vortex formation. Then the thermo well, which is used for measurement of a temperature, a well that is provided in which you are going to put a thermometer or a temperature measuring sensor. So all these are the basic needs of a pressure vessel. Then this is again the another figure you can say related to the simple agitation vessel, a jacketed reactor. This can be drawn in your drawing practical also. So here the baffles they are provided inside the jacket. Then the supports that is also shown in this figure. the nozzles attached to the jacket, the inlet and outlet nozzles which can be provided to the jacket. Then here the more details related to the agitation system that are provided. So all these are your different accessories. Now in this case, it is the same thing, but here the air inlet that is provided, which is the annulus or the sparging ring that is provided inside this. It is generally provided in case of where the oxygen requirement is available or the gaseous phase that is available. There you are using this sparging ring. That means the small bubbles they will be created when you provide the compressed air or compressed gas to this. This helps for your reaction purpose. So this is the separate assembly of an agitator, that is driving motor, speed reduction, mechanical seal, shaft and the impeller blades. So this is the basic requirement of a basic assembly of an agitator. Then this is the industrial scale vessel which you can see. To this vessel the drain that will be provided. Then here the two heads that is provided. One is your bottom head which is the elliptical one, and the top head which is also the elliptical one. Then few inlets and inlets that is provided for instrumentation purpose, for thermowells, for dip legs. All these are the different attachments that will be provided, and then there will be the leg support which is also provided, the four different legs that is welded to this vessel so that it can be stable at its position itself. So this is the general assembly of the vessel. Now this is a huge vessel. From here a drum, you can see the drum here, and you can imagine that what must be the dimensions of this huge vessel that can be. So it must be more than around 5 meters diameter and around 15 to 20 meters in the length. So much huge dimensions of this vessel that will be there. So you can see the different saddle support which is provided in this case. You can specifically see the head which is provided, then the different flange joints that is provided, different it's again a vertical vessel because the support which is provided at the bottom. 1, 2, 3, 4, 5, 6, all these are your supports which are to be provided, and the small inlets or outlets or for measurement of purpose, these different small nozzles, the bigger size nozzles that is also provided, and it is can be insulation that is to be provided for that purpose. Sometimes the studs they are welded to the vessel itself. This is the smaller vessel that you can see. Then again you can see how huge vessel this can be. A certain reactor, this is shown as certain reactor, and you can see the number of tires for this truck, and from there you can see or imagine what must be the dimensions of this huge vessel. So the diameter of the tire that is around 1 meter, and if you will see the diameters of the outlet, these two outlets that is around 1 meter or so, and the it's again the diameter of the vessel in the lower section as well as the diameter of the vessel in the upper section that is going to vary in this assembly. So all these are depending on my process requirement, how much amount of the process fluid that is to be handled. Based on that, I have to decide the dimensions of the vessel. Such a huge assembly, and the special support that is provided for transportation purpose of this huge vessel. Then these are given spherical vessels. These are also called as the Horton spheres. And again, these are the huge one Horton spheres and generally used for LPG or ammonia storage vessels. Staircase that is provided, then all over there is the uh, supports that is also provided, and the inlet outlets, all the assembly accessories, then safety considerations at the top that is also provided, and the platform that is also available at the top of this vessel. So these are your general vessels, how vessels look like. When you go to a certain software, there you can see the certain figures like this. That is nothing but your stack or different types of the vessels. All these are from certain software. And this is again the software developed three-dimensional vessels used for computational fluid dynamics purpose. So you can do it in this AutoCAD or the ANSYS in case of your fluid flow analysis, that is computational fluid dynamics. The nozzles that is shown in that, the flanges that is shown, so the different vessels. I have uh, people work on this to understand the detailing related to the stresses, stress distribution, then pressure distribution, the fluid distribution, all these different studies that can be done with the computational mathematical requirements and the understanding of those, the different software. We have already discussed related to the nature of the process equipment. So the different chemical equipment that is generally used are our reactor, distillation column, heat exchangers, absorption columns, then scrubbers, and all these equipments are. However, the internals that is going to vary. So the designing of this equipment basically requires the designing of a vessel and the designing of the internals. So these internals, that is the separate part, and that goes again from that varies from equipment to equipment. But the basic equipment design, when you talk, that is the what we are going to discuss in this subject is related to this basic design requirements. So that is what we call the vessel design considerations. Now, when it's a vessel design considerations, generally the process engineer or the production engineer, he defines his requirement based on the production capacities. Production capacities is nothing but this much amount of the product that is to be required to be produced. And for this much amount of the product, I am defining a certain my basis that this much is my raw material required. Based on that, I'm going to calculate the volume requirements from my material balance, energy balance, and my reaction kinetics. All these are my basic requirements. So a process engineer provides all this information. Process engineer provides the vessel dimension, volume. Vessel dimensions are defined by the process engineer, and then it goes to a mechanical engineer after that. The purpose or the role of a chemical engineer and the role of a mechanical engineer, that varies. Then various rough designs and detailed designing of the equipment that is also to be carried out initial stages. Now considering one by one the various designing aspects we will study. The detailed design, before doing the detailed designing, one has to consider all these basic parameters which are to be defined by the process engineer. So designing parameters have to be considered before detailed design of any equipment. These basic design parameters which are to be considered are: number one, the vessel functioning. So the vessel functioning itself, function is whether I'm using it for a reactor, heat exchanger, distillation column, absorber, scrubber, liquid separator, liquid entrainment, whether it's a high pressure vessel, low pressure vessel, nuclear reactor, all these are the different functions. The next is the process material. Which process material? When you talk the process material, it is the material which is to be processed. There is a difference between a process material and a material of a construction. Material of a construction, it is different than the process material. Process material, which material that is to be processed? A chemical, we are processing the chemicals in our plant and their basic physical and chemical properties, that is what is needed. Also the special properties are to be also required and its service. The type of fluid handled or being processed, whether it's a gaseous phase, liquid phase, or whether it's a solid or it's a combination of all these different phases. Then when you talk related to the material of construction, whether it's a plain carbon steel or low alloy steel, and the alloys and reinforced plastics that can be used in case of a material of a construction. Then suitability of fabrication material is to be selected from the understanding of the process materials. Then compatibility of this process material with the process environment, that is also needed to be studied. The pressure vessel design codes and standards that include the list of acceptable material in accordance with the appropriate process materials. Means I know the process material, and in case of our designing standards and codes, which materials, which material of construction is suitable for this particular type of a material, particular type of a process material. Then availability of a different materials of construction and their cost data for comparison, that is to be studied before final selection of a material of construction. Then selecting the material of equipment, that is what the material of a construction according to the technical parameters, that is your temperature, pressure, which is the process material, that is nothing but the media, and the principles of material selection. Whether this material of construction is decided by considering the process fluid, corrosive nature, then its operating and design temperature, pressure, then what must be the length of service. Length of service, that is also very much essential before the designing, before the procurement of the equipment. Based on that, how much I have to invest, that is to be decided. Then the material stability in a particular environment. Then material of construction properties, that is allowable stresses of the material, heat transfer coefficients. Then your permissible tensile stresses that can be decided after the selection of a material of construction. Then what must be the necessary volume of storage of the capacity for a certain processing. Now basically this volume, how much volume of the vessel, that is decided purely by a chemical engineer from the basis of your material balance, from the energy requirements, from the mass transfer requirements, and from the kinetic requirements. Our chemical reactor design subject that defines the volume requirement for obtaining these defined conversion for that particular product. So this chemical reaction engineering design that provides the volume for the fabrication of any equipment, for the fabrication of a vessel. Mass transfer equipment, it is obtained from your mass transfer specialist. So the vessel size is decided based on the mass and heat transfer and kinetic data or the process material balance requirement. Now what must be the length and what must be the diameter, that is the vessel dimensions, if you know the volume of a vessel. Generally it's the talk in terms of L by D ratio as well as the D and the thickness ratios, diameter and the thickness ratio. Then the geometry of the vessel and the type of vessel required for process which can be fabricated economically for process requirements. So what must be the shape, how that is to be fabricated. The next is the type of a service required, whether it's a batch process, semi-batch process, continuous process, intermittent or fluctuating, or specifically a seasonal process. So depending on that, I have to decide, I have to select the material of construction, select the dimensions of the vessel. All these parameters are to be taken into account before the detailed designing has to be done. Then welded joint efficiency is also one of the aspects, and that depends on the type of a joint and the quality of a welding. You require the specialty welders for welding our chemical equipment. That is when you talk, that is the class A, class B, class C vessels are there with in accordance with the vessel welded joint efficiency. If it's a class A vessel, then the joint efficiency J, that is considered to be the 1. Class B vessel, J joint efficiency, that is considered to be 0.85. Then if class C vessel that is there, the joint efficiency can be taken as 0.5 or 0.7. So this is the possible lower strength of a welded joint compared with the virgin plate is usually allowed for in design by multiplying the allowable design stresses for the material by the joint efficiency. Whenever you are going to do a welding, the strength of that material that is getting different from the original material, virgin plate, virgin material of a construction I am talking about, fabricated your mild steel or stainless steel or your carbon steel material that is there. So what is the possible load strength that is to be taken, and then the allowable design stresses are to be multiplied by the joint efficiency. So this is the allowable or the maximum permissible stresses of the material used for fabrication multiplied by the joint efficiency J. So this is the role of the joint efficiency that depends on the class of a welding. Now when you talk the welding, then a welder do the welding, but that is to be inspected. So visual inspection is there, and there are certain non-destructive testing inspection that is also there. In that, the radiographic testing, ultrasound testing is there. Then the dye penetration testing, hydraulic test, pneumatic tests are there. Then the eddy current test is available. Magnetic particle test, ion test. These are the different types of the non-destructive tests which are used for understanding the quality of a welded joint. Then this test can measure the wall thickness, then the detection of the surface flaws, if there are any certain flaws on the surface that can also be detected. Then the continuity of the material, discontinuity is of the in the material, that is also can be studied from this different tastes. Then the internal flaws in the vessel itself and the effects of the corrosion and erosion that can also be studied. Nowadays, these ultrasound techniques, they are very much suitable and used very conveniently in the industries for calculation of the wall thickness, detection of the flaws, then to effect of the corrosion and erosion that is very conveniently calculated by using this ultrasound techniques or ultrasound equipments. Then the corrosion allowance, how much that is to be provided. Even though we are selecting the particular material, the corrosion resistant material we are selecting while selection of a material of construction. But still there is a possibility that the corrosion will be taking place in the due course of a time. And for that purpose, while designing the thickness, the corrosion allowance that is to be added in comparison with in addition with the theoretically calculated thickness. So it is the additional thickness of a metal which is added to allow for material loss by the corrosion and erosion or the scaling. So it's the additional thickness of a metal, additional thickness of a metal that is added as a allowance for the basic material addition. So the minimum wall thickness is calculated by using the fully corroded conditions generally. Then corrosion is a complex phenomena, so it is not possible to give the specific rule for estimating the corrosion allowance, and for that the general considerations that is to be done. So for example, the carbon and low alloy steel where the severe corrosion that is not expected, the minimum allowance of the 2 millimeters should be used. So 2 millimeter is added to the basic thickness calculations as a corrosion allowance. For more severe conditions, 4 millimeters can be used. Then the location of a vessel, whether the vessel is located inside the plant or the outside the building, that again affects the corrosion, the surrounding environment. So all these things are going to vary because of this location. Then the shape, the geometry of a vessel, whether it's a cylindrical shape, spherical, conical, square, rectangular, or of a desired suitable consideration. Next is vessel orientation, whether that vessel is vertically oriented or horizontally oriented. So all these design considerations are to be taken into account. And now the more important operating parameters, that is the temperature and pressure, which are very much the basics for our designing. At what temperature I am going to carry out this my process, and for that the strength of a material decreases with the increase in temperature, so that the maximum allowable stresses will depend on the material temperature. So temperature that affects the material of construction. The strength of material decreases with the increase in temperature. So the maximum allowable stresses that has to be taken for the certain suitable higher temperatures. Then under the ASME EPV code, the maximum design temperature at which the maximum allowable stress is evaluated. So you have to first evaluate the stresses at that particular design temperature. Then give allowance for certain uncertainties involved in predicting the vessel wall temperature, whether it can be a malfunction of your temperature measuring equipment, or whether the reaction is going out of control, or whether the certain failures related to the utility systems of cooling water or heating systems that can be. So all these considerations are to be kept in the mind while designing the vessel. Then the minimum design metal temperature should be also taken into consideration as the lowest temperature expected in service. So what must be the lowest temperature and what must be the highest temperature? So its design stresses are to be taken into account at the lowest temperature as well as the highest temperature. So design pressure that is designed to withstand the maximum pressure to which it is likely to be subjected in the operation. The next is the calculation of a thickness. To calculate the vessel thickness, considering it as an internal pressure vessel, and the thickness T that is calculated as PD upon 2Fj plus C. C is nothing but the corrosion allowance, which is taken as the 2 millimeter in general case. So the pressure vessel diameter stresses, then your welded joint efficiency, corrosion allowance, then factor of safety, then over designing of the vessel for expansion of the capacities, all these points are to be taken into consideration. Then what must be the minimum thickness that is required to withstand the given conditions? So generally if the vessel diameter is 1 meter, then the minimum thickness of 5 millimeters has to be taken for the vessel fabrication. As the vessel diameter increases, your minimum thickness requirement that again goes on increasing. So the thickness of cylinder heads and the tubes must be close to the standard grades. Whatever the theoretically calculated thickness that will be there, irrespective of that, we are going for the higher thicknesses, because what is available in the market, accordingly I have to select that particular thickness. So the thickness of cylinder heads and the different tubes, that must be close to the standard grades. If when you talk related to the standard grades, it comes as your 5 millimeter thickness, then 6 millimeter, 8 millimeter, 10 millimeter thickness plates which are mostly available. 10, 12, 14. In case of the pipe length, you go into the 10 feet pipe length or 20 feet or 15 feet, depending on the market availability. One has to select with the specific consideration. Then now considering the design load. What are the different loads that is acting on the vessel? That is also very much essential, very much important, the designing load. A structure must be designed to resist the gross plastic deformation and the collapse under all conditions of loading. So plastic deformation as well as the collapsing load has to be accepted or adjusted by that material of construction. So there are two different types of load. One is the major load and the second is the subsidiary load. Major load, that is nothing but must always be considered in the vessel design. This is must. And subsidiary load, that can be taken into consideration. So first is your design pressure, internal pressure. This is including any significant static head of the liquid, that is the internal pressure. Then second is the maximum weight of the vessel and the contents under the operating conditions. The weight of the vessel itself plus whatever the contents you will be using under the operating conditions. Vessel that is completely filled or vessel that is half filled, based on the density considerations, how to take the weight of the content itself plus the weight of the vessel itself. then the maximum weight of the vessel and the contents under the hydraulic test conditions. For hydraulic testing, I am using the different fluids, generally it's the water that is taken for your hydraulic testing, and at that time what must be the weight of the vessel and weight of the contents that will be there. Next is your wind load. What is the wind velocity, whether it is surrounded outside or whether it is surrounded inside the building, depending on that, the wind velocity, whether you are on the seashore, all these considerations are to be taken. Then the earthquake loads, it is in the seismic area zone or the stable zone. Based on that, my designing should also be taken care of. So loads supported by or reacting on the vessels, that is there. Then the subsidiary loads, that is the local stresses caused by the support, then internal structure and the different connecting pipes. So this is the local stresses caused by the supports, different connecting pipes, different accessories that is attached to the vessel, and that is also acting as this different load. Then shock loads caused by the water hammering, steam hammering, or by surging of the vessel content. Suddenly the vessel contents that increases because of certain failure of the equipment, failure of the control valve, that suddenly increases the vessel content. Then the bending moment caused by the eccentricity of the center of working pressure relative to the neutral axis of the vessel. The different attachments are there. If all the attachments are on the one side,